So here we have trigonometric functions, and don't let the long names scare you off because they're really not as scary as they sound. So right here we just have an angle, and the angle can be described by having certain properties, such as a height of y, a length of x along the x-coordinate, and r. Sometimes we refer to this long side as the hypotenuse, but for the sake of this, we're going to use the variable r. Now, if you remember Pythagoras, to figure out r from x and y, we just take r squared equals x squared plus y squared. So that's one way you can figure them out without using any angles. But if we don't know all of x, y, and r, and we want to find something to do with angles, we can use trigonometric functions. So, starting with sine. Sine is the ratio of the y side to the r side. So, just think of it as, from the angle's point of view, what's directly across from it and the long side. Similarly for cosine, it's the ratio of x to r. And finally, for the tangent function, we think of the ratio of y to x. So, trigonometric functions allow us to use two sides, any two sides, to figure out what the angle is that we're looking at. So if we don't know all three, we can use just the two we know to find the angle. Now, there's also some reciprocal functions. So the reciprocal function of sine is cosine, and in that we just take the y and the r and we flip them over. Just easy to remember, cosine is sine flipped upside down. Similarly, for cosecant, the reciprocal of cosine, we've just flipped over the r and the x. And the same for cotangent. We flip the x and the y. So really, once you have sine, cosine, and tangent in your mind, the reciprocals just come from flipping them over. So let's do an example. So here we know the length of x is 10, and the length of r is 13, and we want to find what angle that is. So we have an x and an r, and we can think in our mind sine relates x and r. Since we know x and r, let's just plug them in. So we have sine we have x 10 and an r of 13. So now we know that sine theta is a ratio of 10 to 13, but we want to know theta all by itself. So on your calculator, there's an inverse function. So when you type it in, you want theta This may look scary, but all you need to look for is the second function button. And here we have an angle of 50 degrees. Let's try a second example. Here we know what the angle is, it's 10, and we know that the x length is 12, and we want to know what y is. So again, we think back to the trigonometric functions, and we know that tan theta relates y and x. So what do we know? Let's plug it in. We know x equals 12 and theta equals 10. So tan 10 equals y, which we don't know, over 12. So just start by plugging tan. We know that this becomes 0.176 y over 12. And if you remember cross multiplying, to get y all by itself, we just bring up the 12. And so we have 12 times 0.176 equals 2.1